Okay, good evening everyone and welcome to this lab session. Today we are going to be talking about the VPC and associated features. So the VPC is the virtual private cloud. Virtual private cloud basically is like your own private space on the AWS cloud. So it's like your own data center on the AWS cloud. The AWS cloud is actually a public cloud. It's being used by several other persons and organizations. So when you get into use the AWS cloud, the first thing to do is to create a virtual private cloud, which is a space of your own, which will help you to actually deploy your resources in a virtual network. So every resource that is deployed in your virtual private cloud in your VPC is logically isolated from those of other VPCs, except you pair the VPCs through VPC pairing or other means. So we're also going to look at subnets because we'll be creating subnets together with the VPC. So as I mentioned, the VPC is a private space that gives you the opportunity to deploy your resources in a virtual network, but that network is a very large network. So subnets come in where you create smaller or like smaller groups of networks, smaller networks, as in the word subnets, smaller networks to maximize the efficiency of your network. Because following the normal classes of networks, a regular network size will contain about 64, I think the list should be 64,000 IP addresses, which is a lot for a network. And you would not find a lot of companies that have so many servers or computers to fill in that space. So subnetting comes in where you create subnets according to how many servers or how many IP addresses you need in your network. So, and when you create subnets, it also enhances the security of your network, because with the subnets, you can configure network access control lists that will help you to control how or what kind of traffic gets into your servers, into your subnets also. And it also enhances the performance of your network, because the smaller the network, the quicker or the higher the speed of traffic transfer. So we're just going to go to our AWS console now. And on the search bar, if you don't already have VPC here on your feature list, you can just search VPC on the search bar here, and you click on the VPC. Well, we are going to start creating a VPC. So let me know if everybody is logged in and at this level, and then we can begin, please.
Yes.
Okay, that's good. Boris?
Yes, I'm in.
Okay. All right. Okay, so when you get to the AWS console and look for this VPC, this is the interface you're going to find. So here we're going to start by creating our VPC. So as I mentioned, is the first thing you should do on the AWS cloud, because it provides a space for you to deploy your resources in a virtual network. So right here on this, if we all have this interface, we're going to see a create VPC orange button here at the top. You can click on it. So it takes us to the view where we create the VPC. So it takes you to this page, and you can either choose to create just the VPC alone. So if you create the VPC alone, you have to then later on manually create your subnets, create your internet gateway, and if you need a NAT gateway, you create it also manually. But with this other option, VPC and more, it will help you to easily create those other features without going to do it from the VPC console. So we're going to choose the VPC and more option here. And then under name tag auto generation, you keep it tick in, you check the box. Just a moment, please. Okay, so we're going to give a name to our VPC under this name tag. Let us name it. We can name it anything, but I'm going to name it Tuesday Lab VPC. Funny name. Tuesday Lab VPC. I'll just use dashes in between. So we're going to give a name to our VPC. The next thing we're supposed to do is to choose the CIDR block of the VPC. We're going to use this proposed one, 10.0.0.0/16. So the CIDR block is already telling you the kind of IP addresses your network is going to have. And if you look at this CIDR block, if you look at this address, you see it's an IPv4 address. An IPv6 one is more complicated, it's longer. I don't want to say more complicated than this. So, but we're going to go just with the IPv4 CIDR block. So you keep this at 10.0.0.0/16. And then you go down to the level of availability zones. So these availability zones now is you're trying to determine where your subnets are going to sit in the physical AWS data center. So we're going to have two availability zones, so you can keep the two checked or highlighted as so. And for the number of subnets, we're going to have 4 subnets. We're going to have 2 public and 2 private subnets, just as it is proposed here. So if you're at this stage now, you can click on customize subnet CIDR block, and let's customize the CIDR block of our subnet. But just before that, let us click on customize ASIS, so we decide which availability zones our subnet should sit in. And by default, I already have US East 1A and US East 1B. I will just propose that for consistency's sake, we should all use this. So you should be deploying your VPC in North Virginia. Here, if you look here, I'm in North Virginia, and that's why they're giving me these options for availability zone. So we'll have US East 1A and 1B. So that's fine for me. We go down to customize subnet CIDR blocks. So we're going to give a CIDR block for our 2 public subnets and the 2 private subnets. So for the first public subnet, we're going to give 10.0.0.10.0/24. Let me know if we are all here. Hello.
Yes, yes.
Okay.
Tatiana,
Yes, Debbie. Please mute one of your devices. I'll just hold on for you to take care of that and then bring up your question.
can you hear me now?
Yes, perfect.
Okay. I was saying to customize ASIS. Did you just let it be at US East 1A, or did you change it?
Yes, US is 1A and US is 1B. Remember, we said we want to have two ASIS. So you can actually look at the drop down and choose any of the availability zones here, but I've kept mine at 1A and 1B.
Then the customized subnets CDR block, did you change it, or you just left like that?
That's where we are now.
Okay.
So we are customizing the first subnet. For the public subnet, the CIDR should be 10.0.10.0/24.
Okay. /24.
Yes, so if you look at it, you see that this CIDR block is going to give us 256 IP addresses, which is smaller and good. So your public subnet can have up to 252 and above of servers. So the second public subnet should be 10.0.20.0/24. It's going to give us a similar number of IP addresses as well. Then for the first private subnet, it will be 10.0.100.0/24. And this one will be .200/24. So each of our subnets is going to have 256 IP addresses available for our devices. If we are all here, then we can go ahead now. Let me know if you are here.
Yes.
Yes.
Okay. So if we look at while creating our subnets, we've decided that we're going to have public, while creating our VPC, we've decided that we're going to have public and private subnets. And with this, when you're using this configuration of VPC and more, the internet gateway is automatically created for you. And if you can look at the preview here, you already have one VPC, and you already have 4 subnets here and the 4 route tables. And you have the internet gateway, as you can already see here, that has been created automatically for you. But now, because we have private subnets, we need to create a NAT gateway. Remember, a NAT gateway is what will enable traffic from your private subnets to the internet. So it directs traffic from a private subnet to the internet, because private subnets don't have servers in the private subnet don't have public IP addresses. So we're going to create a NAT gateway. The recommendation is that for every subnet you create a NAT gateway. For every private subnet, for each private subnet, you create a NAT gateway in the public subnet for scalability purposes. So, but when you create a NAT gateway, you have to pay. So in this case, we are going to use just one NAT gateway. So here we are going to highlight one. So we have one NAT gateway in one AZ that's going to route the traffic both from the 2 private subnets to the internet. So at this level, we'll choose in one AZ. You could choose one per AZ. That means we are going to be creating two. And the the NAT gateway sits in the public subnet, not in the private subnet, when you look at a VPC architecture. So we have selected this. It's going to create a NAT gateway for us. I think if we look at our architecture now, I want to see if we are going to find the NAT gateway here. No, we don't. Okay. Yeah, we do. Yeah, we see a NAT gateway here at this level, the one that is highlighted in blue. So all of these things that we see on this preview, on this lattice, is going to be created when we click the create button. A VPC, 4 subnets, 3 route tables, means 1 for the public and 2 for each of the privates, 1 internet gateway, 1 net gateway, and 1 VPC lattice. So also, I would just let us create this for now, and then we go and check and see all the resources that we have created. Then we'll later on come and talk about VPC endpoints. So at this level, you can make sure that the enable DNS host names is checked, enable DNS resolution is checked, and then you click on create VPC. So when you click on that, you can see all the VPC features being created. You can see the NAT gateway is going to take a bit of time. And after that, after the NAT gateway is created, then the route tables will be created as well.
The private subnet CEDAR block in US is 1A is how many? 10.0 100/24. Can you hear me?
Sorry, I was talking with 10.0.100.0/24.
Okay.
Yeah.
No, it's not taking it.
10.0.100.0/24. Don't forget the last 0. So you are supposed to have 4 digits.
Yeah, it's working.
Okay. Yes. Okay. So just hold on for all this. Okay, the NAT gateway has successfully been created. Okay, everything has been created now. So I believe that we had created a VPC before when we do all of these things manually, but now we have seen that there is an option. You can create a VPC and choose for your subnets and NAT gateway to be created for you. The internet gateway is created also. All right, let's click on view VPC. We click on view VPC, you're going to see the details of the VPC here. You can also check the CIDR. You see this is a CIDR that we inputted. You can see that the VPC is available. See that the DNS host name is enabled and DNS resolution too is enabled. All right, so that's about the VPC. Now we can go ahead and check. So initially, when you create an AWS account, each person, once you create an account, a VPC is automatically created for you, and that's the VPC you use most often. But now we see I have 2 VPCs here. This is my default VPC, the first one, and now the one we created just now, which is a Tuesday Lab VPC. So we can go to our subnets. and see if the subnets were created as well by clicking here on the left panel just below the VPC subnet. So when we click on the subnet, you see that the subnets were created. I'll just pull this a bit so we can see the name in full. So see the first subnet, which is a private subnet in US is 1. The private subnet for US is 1A and then 1B. Then we'll have the public subnet for US East 1B and the public subnet for US East 1A. So the 4 subnets have been created just as we asked for them to be created. We can also go ahead and check at the route tables to see if route tables have been created for us and how the traffic is going to be routed. So you see there's a public route table here that has been created, and then we'll have 2 private route tables, the one for US East 1B and US East 1A. So you see we can click on this route table.
I have a question, Tatiana. Does it mean that for all public subnet we only have 1 route tables?
Yes.
And for the private subnet is 1 route table per private subnet.
Yes.
Oh, okay.
You can see just here explicit subnet association. You see that 2 subnets have been associated to this public route table, but for this private route table, just this particular subnet is associated with it, and for this one, another particular one is associated to it. I think this is because when you're creating your private subnets, not all of them are for servers or for virtual machines. You can have private subnets for servers, you can have private subnets for your databases. So the routing for those 2, though they are all private, the routing policy should be different. How you want traffic to be routed. So from the private subnet with databases, you want the traffic to go from the databases to the servers and then before through the NAT gateway to the internet. But otherwise, for the private subnets for the servers, it just go from the private subnet to the NAT gateway and then to the internet. So that is why it has 2 different route tables. You can always define the routes. So is that okay?
Yes, thank you.
Okay, you're welcome. So we could just click on the ID of the public subnet and we see that it has already been attached to the internet gateway as we see here. So we can look at the routes. Let me just click on the routes here, edit routes, and you see that for the traffic that are local should be within this IP, CIDR block, but for traffic from anywhere else, it should go through the internet gateway. It comes through the internet gateway. So this is what you should normally do manually, but when you use the other VPC and more option, it does this for you. So it has automatically created an internet gateway for you and attached it to your subnet. Okay. Then let's look at one of the private subnet route tables. Here. So for this one, you see that instead of the internet gateway here, you have a NAT gateway. So traffic to the internet, if traffic is leaving from your private subnet to the internet, it passes through the NAT gateway before it gets to the internet. But from the public subnet, it goes through the internet gateway. And if you look at the subnet association, we are going to see it's just a single subnet here. It is associated to it. Okay. What other resource did we create? So we can go to NAT gateway here. and see that our NAT gateway has been created. Of course, we already saw from the route tables that it has been created. So this is the NAT gateway that has been created for us as we asked for it to be created. Now, the network interface is always attached to the NAT gateway. Okay, so this is a quick way of creating your virtual private cloud with the necessary features that you need to start deploying your resources. So if we go to the EC2 instance, for example, now I'm just demonstrating this. If we go to the EC2 instance and we want to launch an instance, if I'm launching an instance here, I would see that I have options to choose which VPC I'm launching the instance into and the subnet. Okay, let's just say I'm launching an instance. I'm sorry, the network is a little bit messy. At the level of network settings here, if I go to edit, I'm going to see that I have the default VPC here. But if I wanted to launch an instance into my VPC that I've created just now, I would have to choose this from the network settings. And when I choose this now, I can decide whether this instance that I'm creating should lie within the public subnet of that VPC or the private subnet. As you can see the different options here. So we have the public subnet in US is 1, that in US is 1A and 1B. And then we'll have a subnet in the US is 1B, the private one as well. So you can decide where exactly, in which subnet your instance should sit and what availability zone it should sit. So that is just to demonstrate the creation of a VPC and how it will help you to deploy your resources. So I'll just go back to the VPC now. Yes.
There's a question on the chat. Maybe you can check.
Okay. I see there are 3 routes in the private subnet. Please, could we look into the third route table? Okay. The route table of the private subnet. Just understood why we have the third route table. Is it okay now? I was explaining that the reason why we have 3 route tables here, we have just a single route table for the 2 public subnets, but we have 2 route tables for each of the private subnets. And as I was explaining, all these private, the 2 private subnets must not necessarily be for your virtual machines or for your instances. You can use one of them for your databases. And so if you use one of the private subnets for your databases, the route table, how traffic is going to be routed from the databases to the internet is going to be different from the way traffic will be routed from the private subnet with the instances to the internet. I don't know if that answers the question. Oh,
yeah, that's fine. Actually, my question was, you see here there are 3 routes, one for VPC, NAT, and local. So the first was at first I didn't understand why we have that first one for VPC, but now I get it. I mean, in it, from the NAT gateways, even though the NAT gateway is in the public subnet, so we need the connection from the NAT gateway to the public subnet. I mean,
yeah.
In the public subnet, yeah. Is that right?
That is right.
Okay.
I think this, yeah, that is right. But when you look critically, this is not a route, right? This first one. Is it a route? I think this is the VPC lattice. Unfortunately, I did not research about what a VPC lattice is. But when we were actually deploying our resources on the preview, you could see that Under networks, you have the internet gateway, the NAT gateway, and then this VPC lattice. Maybe I just quickly check what a VPC lattice is, because this is what it is here.
Okay.
Yeah. So it says a VPC lattice is an application networking service that consistently connects, monitors, and secures communications between your services, helping to improve productivity so that your developers can focus on building features that matter to your business. You can define policies for network traffic management. Okay. So it's probably also a networking aspect that helps to enhance communication between your services. Yeah, but when we look at it from this point, it's actually not something we can define. It's created automatically for us.
Yeah.
Yeah, because we can't actually edit this.
Okay, that's fine. Thank you.
Yeah. I don't know if there is any other question before we go to VPC endpoints and what they are and see how to create one. Did we all succeed to create a VPC and see all the resources that are created together with the VPC?
Yes.
Okay. So when you just look at the VPC console, there are a lot of things here, networking aspects, and each of them have different circumstances where you need them. Like I was mentioning the VPC peering, like I said that the resources deployed in one VPC are logically isolated from that of another VPC, except you actually pair the two VPCs using VPC pairing. So you can do that here as well, if I'm not mistaken. And you can also do side-to-side VPN and many other things here. So if there is no question, we are going to go ahead and create a VPC endpoint. But just before that, I'll explain a little bit what I understand a VPC endpoint to be. So normally we have seen that we've created a NAT gateway so that our instances in the private subnet can access the internet or can send traffic to the internet. But a VPC endpoint now comes in with the aspect of communication between services within the AWS. Like if you want your server, your instance, your EC2 instance in your private subnet, for example, to communicate with an S3 bucket in your VPC, you can use a VPC endpoint. This is going to avoid the traffic from going over the internet. So the EC2 instance can communicate with the S3 bucket without actually going through the internet using a VPC endpoint. And I think it's a more secure way if you actually want to your instance to get maybe very sensitive information that is stored in your S3. You don't want the traffic to go through the internet, maybe for security reasons. So we can create a VPC endpoint, and when creating the endpoint, you define the AWS service that the endpoint is going to be linking your VPC to. So we're going to go ahead and create a VPC endpoint, and then we see how it is. Excuse me. So we're going to go on the, where is it here? Okay. On the route tables, you see endpoints on the left panel. So you click on endpoints here. Oh, and I see that this might already be an endpoint because I tried creating one in the afternoon.
Yeah, actually, because when we're creating the VPC,
Yeah.
we enable the S3 endpoint, like the gateway endpoint during the creation.
Oh, that's the okay. I wanted us to do it afterwards, so maybe I left it checked and then it created automatically.
Exactly.
Yeah, but maybe we should, let me see. Let's just go ahead and see how we can create it by ourselves. We'll click on create endpoints here. And then you can name the endpoint. Let's call it S3 endpoint. So we want the communication between our VPC and the S3 and an S3 bucket. Let's call it S3 endpoint. And then it's categorized under is an S3 is an AWS service. So we'll keep this AWS service checked. And then under services now, here we need to select the particular name. So maybe you just start typing S3 here and you're going to see it's going to filter out all the service names that have S3, and we'll choose the second option, the one that ends with .s3, not outpost, not global access point, the second one that ends just with S3. So you see that when we select S3, the service name to be S3, you have two types of endpoints here, the gateway endpoint, the gateway and the interface endpoint. So with the interface endpoint is what I explained, you've been able to communicate with the eligible, I don't know if it's to say eligible, but the permitted AWS services without traffic going through the internet. And this gateway interface is free, if I'm not mistaken. The gateway endpoint is free, but the interface endpoint, AWS has to create a private link that you use to communicate between the VPC and the AWS service, and you have to pay for this. So we're going to create a gateway interface. So when we select gateway interface, we have to choose the VPC that we want this endpoint to communicate with, and it is our VPC, not the default one. So you click on this. And that now we can choose the particular route table. Choosing the particular route table means we're determining the subnet to which traffic can go between this endpoint and the VPC, the subnet in the VPC, between which traffic can go from the endpoint to it. Let's go ahead and choose the, let me see, the private route tables here, because the essence is so that we can communicate with our, VPC without going through the internet. So we want our servers in the private subnet to communicate with this S3 endpoint without the traffic going through the internet. So we're going to select here the private route tables for US East 1A and US East 1B. And for the policy, you see you can either grant full access between the endpoint and full access between the endpoint and the VPC, or you customize how you want the communication to be. So you can actually write a policy here to determine how you want the communication to be. We're going to go with full access. Then we go ahead now and create the endpoint. There was an error. Okay. As a route destination with prefix list. We'll go ahead and see. Did anybody succeed to create?
Not yet. But maybe with 1A it can work. No.
Let me go just with 1B.
Destination.
So I'll try just with 1B and see if it goes through. It still doesn't go through. Oh, let me see. It doesn't go through still. Did anyone succeed to create?
No, I have the same error. So.
I have a question. That prefix that that we saw in the error message, I think it looks familiar to that entry in the private.
So the latest thing we're talking about here.
Yeah.
Yes. Route table. This already has a route with destination prefix list ID. This.
So was that maybe the endpoint that you created?
That was already created, because actually Boris is saying that when we were creating, I wanted us to come and create the VPC endpoint later on, but when we were deploying, when we were creating the VPC, he said he noticed we had already clicked on the endpoint option, and so it created the endpoint for us already.
Is it can we delete that endpoint? The one that was created.
Oh yeah, it's true. We did not unselect this. So this was selected like this S3 gateway. So it had created the endpoint for us. So let me see when we go to endpoints. Here.
Maybe we can try it with DynamoDB as the for endpoint.
Yeah, DynamoDB and S3. Yeah, those are the two services that so this is the endpoint already created. Let me see if we can delete this and then we create. Yes, you can actually delete the endpoints at the end. Okay. Oh, so let's try to I don't know for DynamoDB if I'm required to have a table before we can do this, but let's just try. So it's still an AWS service. Let me see DB. Okay. Memory. Let me go. Yeah. The DynamoDB one, not the memory one. Yeah, and we'll have a gateway here, so it's possible. We can create it even without having a table, and we select our VPC. And then I'll have to choose a route table again. I'll go with private one in US East 1B, granted full access, and create. Okay, so we've created an endpoint for DynamoDB. So the reason why the S3 endpoint wasn't being created is because we had created it on launching the VPC. this is basically it. And that is all I prepared for today. Maybe if we have some other questions, we can bring them up and we try to demonstrate here before we delete the resources. Or maybe we'll go ahead and create VPC, another VPC, but we'll have to create the internet gateway and NAT gateway manually and then attach it. I don't think there's a reason for that since AWS has already given us a means of automatic creation of those things.
Yes, let's try to create the VPC manually and then maybe pair it with the one that we created automatically using VPC peering connection, if it works.
Okay, let me see. For us to do that, we need to create the VPC in another region, I think, yeah.
Also, we can also create in the same region, it's possible. I think the maximum maybe 5 VPC per regions.
And I also think maybe the VPC pairing thing is deprecated.